First, let's take a look at post-processing, which is where people spend most of their time in TenGun. I've already prepared a set of time series files, and I'll just go ahead and open them. There are several ways to open a file. 1. Click the file icon in the toolbar. 2. From the File menu, open Data File item. 3. By pressing Ctrl-O. 4. Or selecting Files in the integrated file browser, which we'll cover as a separate topic. After selecting the files to read, we get to the File Options dialog. The only option that you really need to worry about at this point is that the time series view is selected. We will come back to the file options later on. The first input file is read and the model is displayed. Notice that you get a new tab, or scene, for each dataset. If you have created multiple scenes, just click the tab to switch scenes. You can rearrange tabs by dragging them with the mouse. And, you can close a scene that you no longer need, or if you want to free up some memory by clicking the X on the tab. But, I'm getting ahead of myself. Also, please notice the counters in the lower right corner. If you are reading multiple files, the extra files are read in the background. And this counter shows you the progress. For example, this might show that so far we have read file number 5, of 10 files. However, for my demo, the input files are all quite small, so all the files are read quickly. Other times you might have dozens of files with millions of data points, so it might take a while to read everything. Now that we've loaded some data, let's take a moment to look at the major portions of the TenGun display. On the left-hand side is a tree view of everything that we've loaded so far, and the clock icon shows that this is time series data. I've only loaded one scene so far, but the tree view can become very helpful when you have loaded many scenes and many files. Now, click the plus sign to expand the tree, and you can see all of the individual files, each containing the samples for one time step. Now let's look at the Help menu at the top. There are lots of important things in here. The first item is documentation, which is in PDF format. Next is the Quick Reference Guide, also in PDF format. This guide contains keyboard shortcuts and mouse usage information. I suggest that you review this once to see how it's organized. Next are the release notes. These are primarily for existing users so they can find out what's new without having to read the Enter Reference Guide. The About This Scene item provides a summary of the active scenes, such as the number of particles and fields, or number and type of mesh elements. Finally, the About Display the software version, your license details, and provides a way for us to communicate regarding your software license. On the right side of the screen is the Integrated File Explorer, which works much like the system's File Explorer. Besides allowing you to browse and open files, the File Explorer remembers your most recent paths in the drop-down list at the top. This is real-time saver when you are navigating all over your system while working on different analysis projects. My preference, though, is to just disable this via the window menu because screen space is at such a premium in an application like this. At the bottom of the display is the log window, where various informational messages are displayed. If you see any red or yellow messages, please read them. You may need to take some action. Finally, you can adjust the window sizes to your liking by dragging the thick border at the edge of a resizable window. Now let's look at the data in more detail. At the top center, notice the field list. This list contains all of the data fields defined in your particular analysis output. Let's switch from displaying the material information to the temperature information. Well, That's not very interesting because the hot material we are interested in is in the inside the relatively cold die. So, let's cut this open using the cut feature. Notice the 3 sets of scissors in the toolbar. These correspond to cutting in the X, Y, and the Z plane. I'm going to rotate the model slightly with the mouse, and perform a cut in the X plane. There are 2 things to notice here. First, there is a yellowish plane in the middle indicating where the cut will occur, and you will be shown a preview. You can use the mouse to drag this plane if you want to cut in a different location. The second thing to notice is the arrow perpendicular to the cutting plane. This is pointing in the direction that you want to preserve. If you want to preserve the other side instead, you can 1. Press I to invert the selection, or 2. Press Escape to restart the cut operation, and then press Shift while clicking one of the scissors buttons to start with the opposite orientation. Let me throw in this side note here. Whenever you want to abort some interactive operation such as cut, you can press the Escape key. Also, many operations that you've already completed can be undone by pressing Ctrl-Z. When you're ready to cut, press Enter. And, voila, we can see some hot material in the middle. Naturally, there are some keyboard shortcuts that are easier to use than using the mouse. Press C for cut, and then X, Y, or Z to select the plane. Now let's filter the data. Filtering can be invaluable when you are looking for edge cases in your analysis results. In the top right of the toolbar, notice the filter setting, where you can type an expression to select a subset of your data. This expression always involves one of the field names and some relational operators such as less than, greater than, and so on. You can even have compound Boolean expressions with and or, although there are some minor limitations here. As a filter example, let's just display particles that are still extremely hot. Your most recent filter expressions are saved, so next time you can select it from the saved expressions instead of retyping it. Finally, one more point for this segment. Notice the camera menu item. This is used to position the view camera to one of 6 locations around a viewing cube. You can sometimes rotate the model with the mouse, but oftentimes this is easier. You can also use keyboard shortcuts, and I most frequently use Ctrl-F for the front view, Ctrl-L for the left view, and Ctrl-R for the right view. The next thing we want to do is to navigate through our time series so we can see our various fields change. First, I'll select the material field and delete my filter. Then, you can display a particular time step by clicking its file name and tree view. However, a more common way to navigate is to just press the N key to move to the next item, or press Shift-N to move to the previous item. And, when you get to the end or the beginning, the display will wrap around to the other end. For this data set, you can see the material flowing into container. Finally, notice that as we scroll through the time series, both the file number in the list and the file name are updated. From the name or the number you can back calculate the time at which you spotted an interesting event.